So we've kind of already talked about zero product property a little bit, so this might seem like something that is total review to you from the other day when we did positive and negatives with quadratics. So basically the zero product property, um, all it says is a and b are real numbers, and if you multiply them together, they equal 0, which means if you think about it, right, how do you multiply numbers together to get 0? One of them has to be 0. So then that means either a is going to be 0 or b is going to be 0. Or technically they both could be 0, right? 0 times 0 is 0. Uh, so we know from our conversations the other day that if we're setting something equal to 0 in this case, we're finding the x-intercepts. When you're solving, that means graphically you're finding your x-intercepts. So if we give you something like this in factored form of x minus 4 and x plus 1, right? That's factored form from when we did our quadratics unit. That means here this says a times b equals 0. Well, the two things you're multiplying together are x minus 4 and x plus 1. So similar to how we found our x-intercepts the other day, you're just going to take that x minus 4 and set it equal to 0, and the x plus 1 and set it equal to 0. Obviously here we would add 4 to both sides and get a positive 4, and subtract 1 and get negative 1. So your two answers here are positive 4 and negative 1. If you were to graph that, you would have x-intercepts at positive 4 and negative 1. So that's the approach we're going to take today. Okay, some of them are going to be a little bit more work because you'll have to factor them first. If they're already in factored form, then your job's a little easier. So if you look at number 1, it's already in factored form, so you can take that x minus 2, set it equal to 0, and the x plus 3, set it equal to 0, right? One or both has to be 0 in order for that to be equal to 0. So one of your answers is going to be 2, and your other answer is going to be negative 3. Oh, let's try that again. Okay, for number 2, you guys remember what squared means. Squared means there's 2 of them. So technically, and you won't have to expand this out, but this is what this means, is x plus 8 times x plus 8. We just don't want to forget that, equals 0. So here, x plus 8 equals 0, and x plus 8 equals 0. So you're going to get the same answer no matter what. You get negative 8 and negative 8. So remember, we talked about, so essentially that means you have one answer of negative 8. So here, these are your two x-intercepts, right? So that would be a graph that has x-intercepts at 2 and negative 3. Here, your two x-intercepts are the same. That means your vertex is the x-intercept at negative 8. Okay. For number 3, here, you want to think about this because you're technically multiplying 4 times c plus 9 times c plus 9 equals 0. You want to remember that the three things you're multiplying together here are the 4, the c plus 9, and the c plus 9. So any one of those three things could be 0 in order to make this a true statement that we set equal to 0. So technically, 4 could equal 0, c plus 9 could equal 0, or our second c plus 9 could equal 0. Obviously, that's a little redundant, but that's mathematically what's happening. Well, 4 equals 0, I'm just going to cross that off. That's not a true statement. That part of it can't be 0, which means it's got to fall to one of the other two, which is the same thing. So your answer is going to be negative 9. Okay, now here, if you look at number 4, kind of the same deal. You have 3d plus 6, 2d plus 5, and d minus 6. Any one of those three could be 0 in order to make that a true statement. So 3d plus 6 could be 0. 2d plus 5 could be 0, or whatever the other one is, which I now can't see, d minus 6 could be 0. So you're going to solve all of those. So obviously we get 3d equals negative 6. You guys don't need to show this work, so d could be negative 2. 2d is negative 5, so d is negative 5 halves. Okay, and d is 6 over here. So you have three possibilities there. So technically that's not a quadratic. It's technically a cubic because you would have 3 x-intercepts. Obviously graphically we're not doing that, but that's what that means. Any one of those three answers is okay. Now, those were all nice because they were already factored out for you. Now we're going to take what we did yesterday with GCF, and we're going to have to factor first and then go through and solve. So if you look, excuse me, if you look, you have two terms here, okay? Your GCF here is a b, so you're going to factor out a b, and then you're left with b plus 6 equals 0. Sorry, that was kind of a poor choice of variables and numbers. My b's and 6's look alike. But remember, you guys, if you do this correctly, when you go to multiply these back together, when you distribute that in, b times b is b squared, b times 6 is 6b. You always want to end up back at your original. That's how you check your work. Now, this looks like our examples above, which means b could be 0 or b plus 6 could be 0. You guys, it's both of these. A lot of people forget the b on the outside. That could be 0 as well. So one of your answers is 0. Your other answer, if you subtract 6 from both sides, is negative 6. Okay. For number 6, okay, remember, if you take a look, it's in standard form, but your leading term is negative, so we want to make sure that our GCF is negative. So between negative 10 and 35, I'm going to take out a negative 5. And between x squared and x, I'm going to take out an x. And then inside, if you look, negative 10, you get 2x, and then you get a negative 7 equals 0. So negative 5x times 2x is where I get my negative 10x squared. Negative 5x times negative 7 is a positive 35x. So again, you guys, there's two of these, negative 5x and 2x minus 7. So negative 5x could be 0, and 2x minus 7 could also be 0. So that means x could be 0 from our first equation, or x could be 7/2 from our second equation. Okay, might be in your best interest now to take a second, try number 7, pause the video, do it, and then check your answer. For number 7, it's again got a negative leading coefficient, so I'm going to take out a negative 6m as my GCF. So then inside I'm left with a 3m, so that when I multiply those back together, I get negative 18m squared. And then here, your GCF is negative 6m, so you need a negative 1 here. Remember, you don't want to lose that placeholder of a 1, or if you distribute this back in, you won't end up at your original. So negative 6m times 3m is negative 18m squared. Negative 6m times negative 1 is a positive 6m. Again, we have two factors going on. We have negative 6m and we have 3m minus 1. So negative 6m equals 0. So one of our answers when we divide by negative 6 is 0. And 3m minus 1 equals 0. So that when we solve, we get 1/3. Okay. Over here with number 8, if you notice, this is different than all the other ones because one side isn't set equal to 0. Well, in order to solve, one side always has to be set equal to 0. So I'm just going to take my 10y and I'm going to subtract it over to the other side. Keep it in standard form, so you have 4y squared minus 10y equals 0, and now it's the exact same thing. Between 4 and 10, I can take out a 2, and then I can take out a y. Sorry, that's a strange 2. Then I'm left with 2y minus 5, so that when you have 2y times 2y, that's 4y squared. 2y times negative 5 is negative 10y. So now you would set 2y equal to 0, and you would set 2y minus 5 equal to 0. So your answers when you solve those two equations, sorry this got a little sloppy since I ran out of room, are 0 and 5/2. Okay. All right, your favorite, a word problem. Number 9, a penguin jumps out of the water while swimming. This action is called porpoising. Not really important for the problem, but that's cool. The height in feet of the penguin can be modeled by that equation where t is the time in seconds since the penguin jumped out of the water. Find the zeros of the function and explain what the zeros mean. So remember, zeros are x-intercepts. So if we have that, that means our y, in this case our h, is 0. So we have 0 equals negative 16t squared plus 32t. So if I'm going to find the zeros, which are x-intercepts, I'm going to go through. My GCF here is going to be negative 16t. And then I am going to be left with, I wanted to take out that negative, and I'm going to be left with t minus 2. So when you multiply these back together, negative 16t times t is negative 16t squared, and negative 16t times negative 2 is a positive 32. So again, we have two factors that we can set equal to 0. 0 is negative 16t, and 0 also equals t minus 2. So if we divide both sides by negative 16, we get 0, and we get 2. So our zeros, or our x-intercepts in this case, would be 0 and 2. So that's our time in seconds. So what does that mean? That means that the penguin was out of the water for 2 seconds. Okay. So you're going to take what we did yesterday with GCF, and now kind of what we already did with x-intercepts, but technically the zero product property, and start your homework.